All right, this is our last example for 8.4. We are going to figure something out here, which is we're flipping a coin, and it's a fair coin. So that means whenever they use the word fair, it means you have equal probability for, let's say, heads or tails. Okay, we don't really, it does say heads up. So it doesn't, we don't really know the two sides, but they do say heads up. So we're assuming just like a quarter. Okay, you're tossing it 888 times. So that's your N. And we know the probability of a coin if it's fair. We have a 50% chance if it's heads, and we have a 50% chance if it's tails. So our probability of success and failure are equal, okay? So we are ready to make an approximation for a probability that it lands heads up at most 450 times. So this is what we're trying to figure out. At most, X is less than or equal to 450, okay? So just kind of think about that and practice those inequalities there. So to do our approximation, we have to start with finding the mean, which is mu equals n times p, and finding our variance, which is n times p times q. Okay, and we've already identified all of these values, so just plug them in. And you should get a mean of 444. Okay, so set that aside. And then over here, if you plug in those values, 888 times 0.5 times 0.5, you're going to get a variance of 222. Okay, so we are ready to find our z-score. Okay, so x minus mu divided by your standard deviation. We got to think, what x value do we use here? Okay, so like I said before, if you think about a number line and put the value that we're trying to figure out, which would be 450, right in the middle, and then think about your upper bound. What if I expanded that by 0.5 on either side? Okay, and then what if we were to graph this like it was in Algebra 1? X is less than or equal to 450. So that would be a filled in bubble, and we would be going to the left. Now, when we pick our X value, if that value is included, we have to use the upper bound, okay? Because we want to make sure that we include that with our calculation, okay? So we like over approximate it. So we would use 450.5 minus our mean, which is 444, divided by our standard deviation, which would be the square root of 222. So we would end up with a z-score of 0.436. Okay, so kind of keep that aside for a second as well. And let's get a visual just so we understand what to expect out of our probability if you were to represent this in a bell curve. Okay, with the mean right down the middle of 444. And 450 would be to the right, okay? And we are trying to calculate the probability that we are less than or equal to this. Okay, so this is just an approximation, so it doesn't have to be exact, but this visual is perfect. So we can see that obviously 450 is to the right of our mean, so we should anticipate an answer being greater than 50%. Okay, so the probability that x is less than or equal to 450 is approximately the probability that z is less than or equal to 0.436. Okay, now once again, we can look directly at our table because our z-score is to the right of the mean. It's a positive value, and we're calculating something less than it. So it follows everything from our table. So if you look and you find this probability, you get 0.6686. Okay, and that's after finding the original probability and adding the value off to the right. Then round to 3 sig figs, you get 0.669 for your answer. And like I said before, that should make sense because we are expecting a probability that is greater than 50.